So we actually calculate whether our grit chamber is going to catch our grit, and in reality, you're simply going to test how fast the the materials sink, and there'll be a variety of different types of materials that you will be testing how fast they sink, and then you have to determine how deep they're going to be in the water column, etc. But we're going to do a stylized one here in 11.1. Will a grit particle radius of 0.04 mm and a specific gravity of 265 be collected in a horizontal grit chamber that is 13.5 meters in length if the average flow is 0.15 meters cubed per second, if the width of the chamber is 0.56 meters and the horizontal velocity is 25 meters per second, and the wastewater is 22 degrees. So we care about a density versus density situation here, and that's the density of the grit versus the density of the water. And as usual, Masson and Davis do some rounding here. We're not going to do it over here, but you'll see. So the settling velocity is from the Stokes 1022 equation, and the wastewater temperature of 22 degrees. The density is going to be 997 kilograms per meter square. The size is 0.04, 265, and that should be mg per liter. And it's 13.4 meters long, 0.56 meters wide, 0.15 meters cubed per second, and it's moving through there at 25 meters a second. So so we again look to a table to find the dynamic viscosity at 0.95 millipascals per second, and then we multiply this by 10 to the minus third to get Pascal seconds, and particle diameter of 0.08 times 10 to the minus third to give us our terminal settling velocity. And you're saying, how did it get that 0.08 times 10 to the minus third? Well, radius of 0.04. All right. So we can calculate it. That gives us all of the information that we need, right? And then 9.8 meters per second squared is, right, the gravitational constant. And so we use the gravitational acceleration times the, if we move over, we'll see those things right here. So the settling velocity is, we just plug it into the formula there, and we end up with 0.006 meters per second. And the cross section is 6 meters. Depth is chamber cross section by the chamber width. And so our settling time there, we had to calculate the depth, is a settling velocity, chamber depth divided by the settling velocity. So we end up with 177 seconds. Yay. So and that's pretty cool. So the liquid is going to be in the chamber for how long? If it's 13 meters by, and it's 0.25 meters per second, we would do a residence time and that's going to equal our chamber length divided by the horizontal velocity. And then it's going to be there 53.6 seconds. Since it needed to be in there 177 seconds, that puppy's going right on out. And our grit chamber's not long enough. Great sadness.